Hey everybody, welcome to another problem session. So today we are going to do this problem in from JEE 2024, Murphy's paper 1. This is a test, entrance test in India for engineering schools. Now this, I'm going to make a little bit of changes in the description, okay? So there's source of sound here, and that source moves in case 1 it moves to the right, and there's an observer which I'm going to call detector, and I'm going to use letter D for it. Okay, so if in this situation we're both moving towards each other, while this thing emits at 240 hertz, this thing detects at 280 hertz, 88 hertz. But when both are moving away from each other, like in case 2, but the speeds are, same speed as before with respect to, now the speed is with respect to some fixed frame outside of these bodies, right? And in the medium. So the question is, what's going to be this? Now this is a classic Doppler problem, Doppler effect problem. So the formula that you find, you can actually learn more about that in this book. But the formula you're going to find is if source is fixed and this thing is moving in the same direction as a line of connecting source with the detector, then frequency will change, and FD will be equal to say speed of sound is C0 in the medium, okay? Then C0 minus V parallel of the detector times whatever the emitted, so what source was emitted. So this is a formula for when just detector is moving, and CS is this C0 is the speed of sound, and there's it is with respect to this fixed frame. And you can see that a V parallel, if this is moving this way, then V parallel will be positive, and if it's moving this way, then it's going to be parallel will be negative, because this side is positive. How about if just the detector is fixed, but you're moving source this way, okay? Again, the fixed frame. The frame is fixed. So this will be source is moving and emitting at F source. So this time the FD will be just flipped over, okay? C0 will be here, and C0 minus V parallel source will have that. So these are the formulas that you may have to memorize to do it very efficiently. Now, if both are moving, then this will be the product of these two effects, right? So F both moving. So the FD will simply be this factor times this factor, and C0 will cancel out. Then C0 minus V parallel D, C0 minus V parallel S, Fs. So having obtained this, we can just apply it to given data. So it says 288, applying to case 1, 288 is equal to C0 minus, this becomes a plus V from the detector, become negative with a negative becomes plus, and this will be C0 minus V and times 200. So you don't need the speed of just this ratio is what we will need. Okay, you will see if we'll set up the number 2 case, then n is equal to now this will become plus because this is going positive direction, then the d will, this v parallel d will be plus, so c0 minus v and c0 plus v and times 240. I'm sorry, 240. That was the emitted frequency. Now this is you can say this and this just opposite of each other. If I just multiply this with that and this with that, this factor will just cancel out. So n times 288 is simply 240 times 240. Therefore n equals to 240 over 288 times 240. And let me just do this calculation here. So okay, let me pause it and do the calculation. Okay, so I went ahead and this carried out this little simplification, and it gives me 200 hertz. So n is indeed an integer, and that's supposed to be the answer in this section, 200, because the unit is already taken out of here, so n is 200. Okay, that was a pretty cool problem. I would definitely, if I were you, try to memorize these things. Okay, it will help you in the future problems. And turns out the Doppler effect is a very popular choice for exams. Okay, so that's it for now. I'll see you in another video. Bye.